Hello everyone and welcome to Concepts to Grades, where we turn all your concepts to grades. In this video, we'll be doing the CBSE Class 9 Science Chapter 7, Motion. Here we will see how motion happens in a straight line, the uniform non-uniform motion, rate of change of motion, graphical representation of it, equations of motion and uniform circular motion. From a CBSE Essay 2 perspective, this chapter has a high weightage of 6 to 8 marks. And this also forms a basis of mechanics which is very essential for you in class 11th. So watch this video until the end and try to understand the concept. Let us start with understanding what is motion. Whenever an object is moving, it is said to be in motion. Well, this is a generic expression. But in science, we define that when an object's position is changing with respect to time, it is said to be in motion. So here the cyclist was at the top of the hill at 7 a.m., was in between the hill at 7:05, and at 7:07, it was at the end of the hill. So since the position of the cyclist has been changing at different intervals of time, we say the cyclist is in motion. Now let us understand the concept of distance and displacement. Let us say there are three friends A, B, C whose houses are on the same street as follows. And you are in the car at O and would like to visit your friends. The distances to each of your friends' house from the place you are standing, which is also called the reference point, is as follows. Now you want to meet your friend A first, then go to B, and then go to C's house. So first, you would have traveled up to A, met your friend A, then moved to B, and then come back to C's house. In this situation, the total path that you have traveled or the total distance that you have traveled is O to A, then from A to B, then from B to C. This distance is given by 20 kilometers plus 10 kilometers plus 4 kilometers, which in total is 34 kilometers. So that is the total distance you have traveled. Now what is displacement? Displacement is defined as the shortest path or the final position minus the initial position of your journey. In this situation, the displacement first position was at O and your final position was at C. Distance between O and C, which is OC, is equal to 6 kilometers. Hence, the displacement is quite different from distance. It is the shortest path or it is the final position from the initial position. Displacement is 0 when the final and initial positions are same. Suppose in the above scenario, after meeting your friend C, if you had come back to O, your displacement would be 0 since your final and initial position are same. Displacement and distance are only equal when the total path traveled is equal to the shortest path length. Now let us go deeper and see how these two vary with respect to time, which gives us speed and velocity. Speed, as we have learned earlier in our earlier classes, is nothing but distance by time. So if a car is traveling on a straight road for 20 meters and it takes 2 seconds to travel this 20 meters, the speed of the car is given by distance by time, which is 20 by 2, which is equal to 10 meters per second. When you travel different path lengths, we try to calculate the average speed, where we calculate the total distance and the total time taken in the entire journey. So in this case, if the car is going straight and takes a U-turn and returns back to the point, the total distance traveled by the car will be 20 plus the other 20, which is equal to 40 meters. And the time taken for this, let's say, is 5 seconds. Then the average speed of the car in the journey would be equal to 40 by 5, which is 8 meters per second. Now let us understand what is velocity. Velocity is displacement by time. So considering the same case where the car is traveling on the straight road of 20 meters, the displacement it traveled is also 20 meters. The time taken is 2 seconds. Hence the velocity of the car is 20 by 2, which is 10 meters per second. We can also say that velocity is nothing but speed with direction. Whenever we consider the speed along with the direction in which the object is moving, it is called velocity. We will see the application of this in the average velocity. Let us say the car was moving straight and then took a U-turn and went back in the opposite direction. Now the average velocity in this case will be initial velocity plus final velocity by 2. Here the initial velocity is 20 by 2, which is 10 meters per second. And the final velocity is minus 20 by 2 because the car was moving in the opposite direction. So that gives you minus 10 meters per second. So the average velocity of the car will be 20 minus 20 by 2, which is equal to 0. Average velocity can also be calculated as total displacement by total time taken, where here the total displacement is 0 since the final and initial position are same. Hence, the average velocity is 0. Let us solve an example to understand things better. Ram travels 2 kilometers to the market by walk to get groceries, and this takes him 30 minutes. Seeing that the market is closed, he returns home in an auto along the same path, which brings him home in 2 minutes. Calculate the average speed and average velocity of Ram. Let us start by calculating the average speed. The average speed is given by total distance by total time taken. So the total distance here is 2 kilometers going and 2 kilometers coming back, which is equal to 4 kilometers, which is nothing but 4,000 meters. Now the total time taken was, for going he took 30 minutes and coming back 2 minutes, which is 32 minutes. In seconds, that would be 920 seconds. So the average speed will be 4,000 by 920, which is the total distance by total time taken, given by 2.083 meters per second. This is the average speed. Now let us find what is the average velocity. Average velocity can be given by total displacement by total time taken. So the total displacement in this case is going to the market was 2 kilometers. Coming back will be minus 2 kilometers, as we have to consider the direction of motion when it comes to velocity. So the total displacement is 0 kilometers. You can also say that since the final and initial position are the same, which is the house, the displacement is 0. Now again, the total time taken remains the same, which is 30 plus 2, 1920 seconds. Hence, the average velocity will be 0 by 1920, which is equal to 0 meters per second. This is how you calculate average speed and average velocity. Now, let us understand the two different types of motions that are present: uniform and non-uniform motion. In uniform motion, an object covers equal distances in equal intervals of time. That is, let's say there is a road and there is a bus which travels 20 meters in the first 5 minutes, 20 meters in the next 5 minutes, and 20 meters in the next 5 minutes. In every similar equal interval of time, it is covering the same distance. Hence, this is called uniform motion. Here, the speed or the velocity is constant with respect to time. There is no change in the speed or velocity over time. Let us understand what is non-uniform motion. If the same bus covers unequal distances in equal intervals of time, that is, in the first 5 minutes, it covers 10 meters, but in the next 5 minutes, it covers 30 meters, and in the next 5 minutes, it covers 20 meters, it is said to be in non-uniform motion. This is the kind of motion that we see in our everyday life, where we start slow and we increase the speed with time. Here, the speed and velocity is not constant with respect to time. They change over the time. Let us understand what happens when there is change in velocity over time. We define that as acceleration. Acceleration is change of velocity with respect to time. So considering the similar situation of the bus, which took 10 meters in the first 5 minutes, 30 meters in the next, and 20 in the next 5 minutes, acceleration is calculated as final velocity minus initial velocity by the total time taken. So in this case, the final velocity was 20 meters in 5 minutes, that is 4 meters per minute. And the initial velocity was 10 meters in 5 minutes, which is 2 meters per minute. And the total time taken was 5 into 3, which is 15 minutes. The acceleration is given by 4 minus 2 by 15, which is 0.133 meters per minute square. So acceleration is given by final velocity minus initial velocity by the time taken. Let us solve an example to understand this better. If a train attains a velocity of 20 meters per second from initial velocity of 0 meters per second in 10 seconds, later if the train slows down to 10 meters per second in the next 5 seconds, calculate the acceleration in both the cases. First, let us solve the case where the velocity has increased from 0 to 20. Here, the initial velocity was 0 and the final velocity was 20 meters per second. The time taken to do this change was 10 seconds. So the acceleration is given by v minus u by t, which is 20 minus 0 by 10, which is equal to 2 meters per second square. Coming to the case 2, where the speed was slowed down from 20 to 10, the initial velocity was 20 meters per second, the final velocity was 10 meters per second. The time taken to do this was 5 seconds. So the acceleration here was v minus u by t, which is 10 minus 20 by 5, which is minus 10 by 5, which is minus 2 meters per second. This is how we solve questions related to acceleration. Let us now move to graphical representation of motion. Let us consider the uniform motion example that we saw earlier, where the bus covers 20 meters every 5 minutes. So here, if we plot this as a table, at 0th minute, the distance traveled by the bus is 0 meters. At 5 minutes, it traveled 20. In 10 minutes, it traveled 40. And in 15 minutes, it traveled 60. So plotting this distance and time as a graph gives us a distance time graph which forms a straight line. Now the slope of the distance time graph, which is y2 minus y1 by x2 minus x1, which is nothing but s2 minus s1 by t2 minus t1, where s represents distance here, gives us the speed of the object. So we can use distance time graph to find the speed of the object. Now what happens when the object was in non-uniform motion? Plotting the same example that we have taken in the form of a graph, it looks non-linear. So what we interpret from distance time graph is, the slope of the distance time graph gives us the speed of the object. If the distance time graph is a linear straight line, then it is considered to be in uniform motion, where the acceleration is 0. That is, the speed or velocity do not change with respect to time. If the graph of dt is non-linear, it is non-uniform motion where the acceleration exists and it is not equal to 0. Let us solve an example to understand this graph better. The graph here shows 3 cars A, B, C traveling. Interpret the graph and arrange the cars in ascending orders of their speeds. Are all 3 cars at same point on the road in their journey? How far has A traveled by the time it meets C? So let us do the first one, where we arrange the cars in ascending order of their speeds. So speed from the dt graph is given by the slope from the dt graph. So for A, if I want to calculate the slope, from the interval 5 to 10, the distance it traveled is 40 at 10 and 20 at 5. So it is 40 minus 20 by 10 minus 5, which is equal to 20 by 5, which is 4 meters per second. B has gone from 0 to 40 in the interval 10 minus 5. So the speed will be 40 by 5, which is 8 meters per second. C has gone from 30 to 40 in the interval 5 to 10. Hence, it will be 10 by 5, which is 2 meters per second. So the ascending order of their speeds will be 2 meters greater than 4 meters greater than 8 meters, which is nothing but C is greater than A is greater than B. So that is the ascending order of their speeds. Now, to answer the next question, are all three cars at same point on the road in the journey? Yes, there is a point in the graph where all three lines meet, which shows that all three cars are at a distance of 40 meters at the same point of time. Next, how far has A traveled by the time it meets C? A meets C at 40 meters. So A has traveled 40 meters by the time it meets C. This is what we can conclude from this graph. Let us now move to velocity time graphs. Consider a train moving on a track where its initial velocity was 10 meters per second in the first 5 seconds, and it was 20 meters per second in the next 5 seconds and 30 meters per second in the next 5 seconds. So the velocity has been changing with respect to time. So if we plot a graph of this, we get a straight line between velocity and time. The interesting part of this is the area under the curve of this graph gives us the distance traveled by the object. So let us understand this better. If we want to find the distance traveled by the car between 5 to 10 seconds, we can find the area under the curve between 5 and 10 seconds, which gives us the distance traveled. So here the area is area of ABCD plus the area of the triangle ABE. So ABCD is a rectangle, so AB into AC plus ABE is a triangle, so half into base into height, which is half into AB into EB. So substituting the values accordingly, where AB is 5 and AC is 10 and EB is also 10, we get that the distance traveled is 75 meters. So this is how we use the velocity time graphs to find the distance traveled by the object. If we consider uniform motion, where the velocity of the train remains constant at every instance of time, where it is always 10 meters per second, the graph is a flat line parallel to the x-axis. Again, even here we can find the distance by finding the area under the curve. But when it's a flat line, when the velocity time graph is a flat line, we can interpret that it is a uniform motion. So what do we understand from velocity time graph? Area under the velocity time graph gives the distance traveled by the object. And if we have a flat graph, it is uniform motion where the acceleration is 0. And if we have a linear graph, it is a non-uniform motion where the acceleration is not equal to 0. Let us solve an example to understand this better. The graph shows the speed and the time of the car traveling. Interpret the graph and find how far the car has traveled in the first 10 seconds. During what time was the car in uniform motion? So let us find the distance traveled by the car by finding the area under the graph between the first 10 seconds, which is the triangle ABC, which is equal to half into base into height, which is half into AB into BC, which is equal to half into 10 into 40, giving us the distance traveled as 200 meters. The uniform motion occurs in a VT graph when the graph is a flat line. So the flat line occurs from 10 to 25 seconds where the car is in uniform motion. This is how we interpret the VT graph. Let us learn the equations of motion. So when an object moves along a straight line in uniform acceleration, which is no change in acceleration with respect to time, the velocity, acceleration, distance and time are related to each other through the equations of motion, which are given by V is equal to V naught plus AT, S is equal to V naught T plus half AT square, and V square is equal to V naught square plus 2AS. Here V represents final velocity, V naught or U represents initial velocity, and S represents the distance traveled, T represents the time taken. You will learn the derivation of these in your higher classes, but for now let us learn how to use these equations to find different values as per the question. The first example, a train uniformly accelerates from 4 meters per second to 28 meters per second in 10 seconds. Calculate the acceleration and distance covered by the train in that time. So if the initial velocity here is 4 meters per second, the final velocity is 28 meters per second, and the time taken is 10 seconds. We need to find the acceleration and distance. So acceleration is given by v minus u by t, which is 28 minus 4 by t by 10, which is 24 by 10, which is 2.4 meters per second square. And the distance travelled is given by the equation of motion ut plus half at square, substituting the values 4 into 10 plus half into 2.4 into 10 power 2, which is equal to 40 plus 120, gives rise to 160 meters. This is how we can calculate. Let us solve another example to get a better understanding. A car accelerating at 10 meters per second square, when brakes are applied, comes to a stop in 2 seconds. Find the distance travelled by the car in this time. So the acceleration of the car is 10 meters per second square. The final velocity is 0 because it comes to a stop, and the time taken is 2 seconds. So if we have to calculate the distance travelled, which is s equals to ut plus half at square, we do not have the initial velocity of the car, which is u. So we can use the other equation, v is equal to u plus at, to find the initial velocity. So u will be equal to v minus at, where v is 0 and a is 10 and t is 2. Substituting, we get that initial velocity is 20 meters per second. Now substituting this into our distance equation, we get 20 into 2 plus half into 10 into 2 power 2, which is equal to 40 plus 20, which is equal to 60 meters. This is how you can use 2 or 3 equations simultaneously to solve the question. Let us solve another question to understand these equations further. A ball is dropped from the height of 45 meters and its velocity increases uniformly at a rate of 10 meters per second square. After what time it will strike the ground and what will be its velocity? So let's consider that there is a building which is of 45 meters height and a ball is dropped from top. So when a ball is dropped from top, we say that its initial velocity was 0 and its acceleration as given in the question is 10 meters per second square, and the distance it travels would be the length of the building, which is 45 meters. So what is the final velocity and the time taken by the object? So let us use our distance equation to find the time. So if we substitute s equals to 0 into t plus by half into t square, we get 45, which is the distance, is equal to 5t square. So 9 will be equal to t square and t will be equal to 3 seconds. So since time is 3 seconds, the final velocity will be given by u plus at, which is 0 plus a, which is 10 into 3. So v will be given as 30 meters per second. So it falls on the ground in 3 seconds and the velocity with which it strikes the ground is 30 meters per second. Now let us understand what happens when the objects are moving in circular motion. We know that acceleration is nothing but change in velocity with respect to time. Now this change in velocity could be change in magnitude or in direction. In our example that we have taken, if the bus moves back in the opposite direction. So when an object moves in a circular motion, the magnitude remains same, but it changes its direction at every instant. Consider an ant moving in a circle. You can observe that every instant of time, the direction of its motion is changing. So in this case, the magnitude of its velocity, which is nothing but the speed, remains constant, which is given by 2 pi r, which is the distance it travels, which is the circumference of the circle, divided by the time it takes. Let us solve an example to understand this better. A boy spins a stone in the circle using the string of length 14 meters. The stone spins in uniform circular motion for 5 seconds before it falls off. What was the speed of the stone during its uniform circular motion? Here, when a person has tied a string to a stone and is rotating it, the length of the string is nothing but the radius of the circle in which it is moving. So the length of the string here is 14 meters. So the speed will be 2 pi r by t, which is equal to 2 into 22 by 7 into 40 divided by 5 seconds. So which is equal to 88 meters per second by 5, which is equal to 17.6 meters per second. This is how you solve questions related to uniform circular motion. I request you to please practice all the NCERT exercise and example questions now. Now that you have studied the concept, the answers will just flow. If you are stuck anywhere, do not worry and comment below your doubt and I will provide you the solution. So in this video, we saw the CBSE Class 9th chapter Motion, where we understood the difference between distance displacement, uniform motion, rate of change of motion, graphical representation of motion, equations of motion, and uniform circular motion. I request you again to practice the NCERT exercise and example questions. Remember, if you do not understand this chapter, you will not understand the next 3 chapters of your physics. If you are stuck anywhere, do comment and I'll provide you the solution. Subscribe to the channel. Like this video if this has helped you understand this chapter much better.